So this unit is on exponential functions. We've got the timeline on the front of the unit. Okay, so running through up to when the test is. So we're going to start today with a review of exponent laws. So a power is comprised of a base and an exponent. So the base in this case is a, the exponent is n. Radicals are comprised of a radicand, that's the thing you are taking the root of, an index, that's which root you are taking. So if we're doing a square root, what do you see here for n? Nothing, right? You don't see anything. So if there's no number in there, then it's a square root. Otherwise, cube root, you'll see a 3, fourth root, you would see a 4. And we've got the radical sign, the radical symbol. Okay, so let's just run through the exponent laws. So we've got the product of powers. So if we have a to the power m times a to the power n, when we multiply powers with the same base, what do we do with the exponent? We add them. So a to the m times a to the n is a to the m plus n. So 3 squared times 3 to the 4th will be 3 to the 2 plus 4, which will be 3 to the 6th. Now, sometimes we care about what 3 to the 6th is, right? We think we can get out our calculators and work it out. And in this case, we don't really. It's 729. Okay. And in this one, then, we have an expression, 3 to the x times 3 to the 4 minus 2x. So that will become 3 to the x plus 4 minus 2x. Actually, when there's binomials, I like to put stuff in brackets. Just separate it out. It's not going to matter here because it's a plus. So that just becomes 3 to the x plus 4 minus 2x, which is, let's go up here, 3 to the negative x plus 4. Okay, so then we add our x's together, and we've got the numbers, right? So x plus negative 2x, or we would just say x minus 2x, and x minus 2x is negative x plus 4. Divide. When we divide, what do we do with the powers? Okay, we subtract. So it's a to the m minus n. This will be 6 to the 8 minus 2, which is 6 to the 6th. And your guess is as good as mine, so we would use a calculator to work that out. And 6 to the 8x squared divided by 2x will be 6 to the 8x squared minus 2x. So what we have to watch out for in this instance is if it was minus and it was a binomial, like up here, we got to watch out for that, because then the minus, we would want to definitely make sure we have brackets around this so that we would then expand it and carry the negative through the brackets and get our expression. Power of a power. Power of a power, what do we do with the exponents? Multiply. So a to the m raised to the power n is a to the mn. 3 squared to the 4th is 3 to the 2 times 4 is 3 to the 8. Which would be a lot bigger, right? We'd have to work that out in calculator. This 3 to the 2 bracket, so we're multiplying, right? But because that's 2 terms, put it in parentheses, right? And then do the multiplication, we're going to use distributive law, and we'll get 3 to the 8 plus 2x. Okay, 3 to the 8 plus 2x. So make sure that you're using distributive law. We're going to run into that a reasonable number of times in this unit. Power of a product. So product, when you multiply two things together, we've got a times b to the m, and that is simply the product of the powers. So it's a to the m times b to the m. 2 times 3 cubed would be 2 cubed times 3 cubed. Okay, now we might think about writing it as like 6 cubed and then But in this case, we're going to write it as 2 cubed times 3 cubed. Because 2 times x to the power of 4 is 2 to the 4th x to the 4th. So each of these has a power of 1, right? Sort of the same here. The 2 here is a 2 to the 1 and a 3 to the 1. So it's 2 to the 1 times 4, just 2 to the 4. But a lot of people, when they write this, they'll write it as 2x to the 4th, forgetting that the 2 must also be raised to the power. Okay? So it's 2 to the 4th times x to the 4th. Power of a quotient, a over b, is the quotient of the individual powers. So a to the m over b to the m, where b cannot be 0. So in any quotient, we know this from rationals, you can't have an expression where the denominator is 0. 3 over 4 cubed will be 3 cubed over 4 cubed. And more generally, because we're going to see expressions of variables, x over 4 cubed is x cubed over 4 cubed. What does a 0 exponent give you? 1. So a to the 0 is 1. 6 plus 1 to the 0. Anything in brackets. So if you got a big set of brackets and you're thinking, well, I got a lot of work ahead of me here to work out what's in there, always look to the outside. Oh, there's to the power of 0, so whatever is inside there doesn't matter. Anything to the 0 is just 1. You got x squared plus 1 to the 0, just 1. A negative exponent, so if you think about, exponents, so if you think about like x squared or something, or 3 squared, 3 squared means 3 times 3, right? Multiply 3 by itself 2 times. That's the exponent. 3 to the 4th is 3 times 3 times 3 times 3. Multiply 3 by itself 4 times. Well, what does a negative exponent mean, right? So if I have 5 to the negative 2, so I multiply 5 by itself negative 2 times. Yeah, that doesn't make any sense. I can't do that. So to make sense of a negative exponent, we turn them into positive exponents. And we do that by putting it in the denominator if it's in the numerator. Okay, so if we have a negative exponent in a denominator, in the bottom of an expression, we just move that part of that expression up top and change the exponent to positive. So you change a negative exponent to positive by putting it, if it's in the numerator, so think of this as a fraction over 1. If it's in the numerator, you move it down to the denominator, you change the exponent to positive. It's only the exponent that changes, it's not the number. So if that was negative 5 to the negative 2, we wouldn't change the negative on the 5. This just becomes 1 over 5 squared, 1 over x squared. And so negative exponents change to positive by moving them. If they're in the numerator, move them down to the denominator, vice versa. Fractional exponent, a to the m over n. The bottom number tells us what root. Okay? It's the index, goes in the index. The top number tells us drink. Mask on. Yeah, you pull it down to drink. You don't need to leave it down. Another way to say this, especially when we're dealing with a number, is instead of taking the power first and then taking the root, we can take the root and then raise it to the power. So using a calculator, if you're using a calculator on this, it doesn't really matter what you do, right? Just go like this, 9 to the power of 3 halves. But if we're doing this, we can write this as the square root, because that's a 2, of 9 cubed. Okay, I'm going to put a 2 there, but you don't normally put the 2 there, right? Just to remind you, square root. So you got to cube the 9, right? 9 times 9 is 81, times 9 is 729. And then you want the square root of 729. Okay, anybody know that offhand?
81.
Nope. Good try though. It's actually 27. But the other way to do this is, let's do the square root of 9 and then cube that. What's the square root of 9?
3.
3. What's 3 cubed?
9.
27, right? So we can all do this. So if you're, if you want to do it by, if you're doing it in your head, take the root, right? So if they're numbers like 16 or 9, it's a square root. We know those, right? We just look at it and say the square root of 9 is 3, and then 3 cubed is 3 times 3 is 9, times 3 is 27. 9x to the 3 halves, this is a product, so it's 9 to the 3 halves, and then x to the 3 halves. Okay, so this could be evaluated, as we've said, from here is 27. And it's kind of the same deal with a fractional exponent, right? So 9 squared is 9 times 9. 9 cubed is 9 times 9 times 9. 9 to the 3 halves is what? It's not 9 times 9 1.5 times, right? 3 halves would be 1.5. Can't multiply a number by itself 1.5 times. So when we see a negative exponent or a fractional exponent, we need to change the form, right? So this becomes 1 over 5 squared. Oh, I can square 5, right? This will be 1 over 25. This becomes not 9 to the 3 halves, but the square root of 9, 3 cubed, which is 27. All right, simplify. Express the answers with positive exponents only. So a lot of times we may want our answers just as a positive exponent. So for this guy, you can go p to the 4 plus 10 over p to the 11. So we're using product of the power. When we multiply powers with the same base, we add the exponents. That would be p to the 14 over p to the 11. When we divide powers, we subtract the exponents. And we'll get p cubed. So that's kind of a multi-step way of doing it. But we can do this in one step. So we can go, it's p, so we've got 4 plus 10 because we're multiplying, and then we're dividing, so we'll go, it's p to the 4 plus 10 minus 11, which is p cubed. Okay, and there should always be equal signs in front to show this expression is equal to. So it's p to the 4 plus 10 minus 11. So you can do it either way. You can work out the top, and once that's solidified, you got a solid value for it. Where you go. Doing expressions like this, we deal with the numbers first. So negative 48 divided by 6 is negative 8. D, we're subtracting, so it's going to be 5 minus negative 2. So 5 minus negative 2, which is 5 plus 2, which is 7. Now, if you want to go straight to the answer there, that's fine. Okay, so I'm just breaking it down. We'll show you the steps. So you do as much work as you need to, whatever you need to feel comfortable when you're doing the question. If you need to show a little bit more work, show a little bit more work. If you want to, a piece of scrap paper, ask for scrap paper during the test to do your work on. Okay, but you do what you need to do to get the answer. So 5 times 2, negative 2 is negative 10. Okay, then we're multiplying powers with the same base. They both have a base of x. We're going to add the exponents, 3 halves plus 5 halves, which will be 8 halves, and 8 halves is 4. The final answer, negative 10x to the 4th. 5p to the 4th to the negative 2. So something, this 5p, it's being raised to a negative power, then we move it, okay? So just say, if you see a negative exponent, just write the thing over 1, write it as a fraction, and then say, okay, now what I'm going to do now is I'm going to move the negative exponent into the denominator, and it becomes 1 over, and then this will become a positive exponent, so we get 1 over 5 we work that out, it'll be 1 over, so it'll be 5 squared p to the 8th, or 1 over 25 p to the 8th. Okay, so that's just simplifying. So in the end, we want to simplify the result. So everything's in brackets. I'm going to do the negative 2 to the 6th, and then the x to the 3/2 to the 6th. So negative 2 to the 6th, we can just evaluate. If you're doing it on your calculator and it's a negative, make sure you go bracket, negative 2 bracket, then raise that to the 6th. An easier way to do that is just to go 2 to the power of 6, because a negative raised to an even exponent will be a positive. Right? So think about it, it means negative 2 times negative 2 times negative 2, 6 times. You'll have 6 negative 2's, the negative signs will pair up, and it'll end up being positive. So this will be 64. 3/2 times 6 is 18 over 2, which is 9. Okay, so you can just simplify. Now, order of operations tells us you got to do brackets first. Okay, there are brackets here, but there's nothing to work out inside them. Then exponents. So we're going to do this first. I'm not going to multiply negative 4 times 8. I'm going to cube this first. So it'll look like this. I'm going to have negative 4 cubed. I'm going to have a to the negative 2 cubed. And I'm going to have an 8a to the 7. Negative 4 cubed, when you cube a negative, what do you get? You get a negative, right? Because now you're multiplying negative 4 times negative 4, which will be positive 16, times negative 4, which will be negative 64. I've got a to the negative 6, okay, and we'll bracket that, and then I've got 8a to the 7. So I have negative, see, now there's no more exponent on this. So since the exponent's gone, I can just do the multiply. So I have negative 64 times 8, which is negative 512. And I've got a negative 6 plus 7, which is 1. So it's negative 512a. Very Canadian answer. Negative 512a. Any questions on any of those guys? Okay. Evaluate each of the following without a calculator by converting each to radical form and then simplifying. So a lot of what we do in exponents and logs and that is converting between different forms. So here we're converting the exponential form, 16 to the 1/2, to the radical form, which is the square root of 16. So remember, fractional exponent, the bottom number is what root, so it's a second root or square root, and the top number is what power, and we're going to raise that to the power of 1. So anytime you see a fraction with a 1 on top, all you're doing is taking whatever root is on the bottom. Okay, so in this case, 2 on the bottom is just the square root of 16, which is 4. All right, we can't do negatives, right? So we got to handle this in 2 steps. So the first step is we turn this into a positive by going 1 over 64 to the positive 1/2. Then we turn it into radical form. So 1 over the square root of 64, which is 1 over 8. Okay, so negative exponent, first change it to positive. Then change the rational exponent into a radical form, and then solve. So since there's a 1 up top and a 3 on the bottom, this is just the cube root of 125, which is, what is 5? 5. The cube root of 125. Y'all know how to do cube roots on your calculator? Okay. So there is a cube. If you go in the math menu, there is a cube root, or you can just go 125 to the power of 1/3, right? And you'll get the same answer. 27 to the negative 2/3. Okay, so first step, got to have a positive exponent, so it becomes 1 over 27 to the 2/3. Then we convert from exponential form to radical, so there's a 3 on the bottom, it's the cube root of 27. We're going to do that first, then we'll square it. Okay. Now I could do the squaring first. I could go 27 squared, and then we could take its cube root, but this is easier to do, right? It's easier, we don't need a calculator, because it says without a calculator. So the cube root of 27 is 3, that's being squared, so 1 over 9. Okay, so fractional exponents, if they're negative, change them to positive. Oh, we'll do something special with f. So e, 16x to the 4th to the 1/2. So you can say, well, it's product of a power, so it's 16 to the 1/2, x to the 4th to the 1/2. This is the square root of 16. This is x squared, right? We have power to a power. So 4 power to the 1/2. Multiply the exponents, 4 times 1/2, which gives us 2. Square root of 16 is 4, so we get 4x squared. Okay. Answer, we get 4x squared. If you have a rational, 64 over x squared, and it's raised to a negative exponent, then what we do, to change the exponent to positive, we just flip the rational. And then we can change the exponent to positive. So we could split it out, right? It's a quotient to a power, so we could write it as 64 to the negative 1/2 over x squared to the negative 1/2. Then we'll make them positive by taking the 64 into the denominator and taking the x squared into the numerator. But when we see that fraction and a negative exponent, we can just flip the fraction, take the reciprocal of this, and turn that to a positive exponent. Then it becomes x squared to the 1/2 over 64 to the 1/2. Power to a power multiply, 2 times the half is 1. 64 to the half is the square root of 64, which is 8. Okay, so we end up with x over 8. Product to a power is the product of the individual power, so 125 to the 1/3 times x to the 6th to the 1/3. 125 is the cube root of 125, so make sure there's a 3 in the index to indicate that. X to the 6th to the 1/3. 6 times 1/3 is 2. Cube root of 125 is 5. So we get 5x squared. So it's a negative exponent. In a sense, this is not a fraction, right? It's not like this. This 64 over x squared is a fraction. We kind of make it one, put it over 1, and then that just reminds you, okay, I can flip this, get 1 over 27x to the 9 to the power of, and then change your power from negative to positive. So in this case, we just take the reciprocal of 27x to the 9. Right? Or think of it as being over 1 and then just flip it. So 1 over 27x to the 9, then make the power positive. So we get 1 over 27 to the 2/3 times 1 over x to the 9th to the 2/3. So again, this is a product, right? 27 times x to the 9th. And the power of the product is the product of the individual powers, so 27 to the 2/3, which translates to the cube root of 27 squared, 1 over, so don't forget 1 over. So 1 over cube root, okay, the 3 tells us we're doing a cube root, and the 2 tells us that we're going to take that result and square it. And this is 9 times 3 halves, which would be 18 over 3, which would be 6. So that's x to the 6th. And you just do that on your calculator. Just go 9 times 2/3. And we got the cube root. So 1 over 3 squared times 1 over x to the 6th will be 1 over 9 x to the 6th. So the final answer for that one is 1 divided by 9x to the power of 6. Any questions so far? Nope. Express each of the following as a power, so we have to go both ways, right? We have to go from. Okay, half sec. Yep.
I was just finishing copying that down.
Oh. Move it back. So we have to go both ways. We have to go from exponential form to radical form, and from radical form to exponential. That's a square root. So a square root is just going to be x to the power of 1 over 2. Remembering that the number in the denominator, the bottom, is the root, what root, and the number up top is what power. So the number in the denominator is what root. So it's a cube root, 3 in the denominator, and it's 5 that's being squared, so the power goes up top in the numerator. So 5 to the 2/3. Here, let's kick up a bit, give ourselves some room. 5x over x to the power of what? 3/4, right? Cubed, so that's what power? 3. What root? 4th root, 3/4. So that would be 5x to the 1 minus 3/4. So remember, anytime there is no number, there's no exponent, that exponent is actually a 1. Here we're dividing powers with the same base. They're both x's, so we go 1 minus 3/4. How many quarters are left? 1/4. Right? So 1 minus 3/4 is 1/4. 1 is 4 quarters, right? Like $1 is 4 quarters. Take away 3/4, you're left with 1/4. Literally change the. Write each of the following as a single power with a base of 2 or 3. Okay, so this is going to come in handy because we will be solving equations algebraically where we need to get things having the same power so that we can simplify an expression. So what's 32 as the power of 2? We know it's not a power of 2. So 32 is 2 to the power of? You can't, I would just use my fingers, right? So 2, next one is 4, then 8, 16, 32. So 2 to the 5th. If you're not sure, do it on your calculator. So 32, okay, is that 2 to the 4th? No, that's 16. 2 to the 5th? Yes, that's 32. If you guess too high, is that 2 to the 7th? No, that's 128, and so on. 2 cubed. Okay, that is a power of 2. What's 4 as the power of 2?
2 to the power of 2.
Yeah, 4 is 2 squared. So the 4 gets replaced with 2 squared, and the x stays. So we're replacing numbers with powers of 2 or 3, and the reason now is we can do power to a power. 2 squared to the x, power to a power is 2 to the 2x. Okay, and now we simplify by multiplying powers with the same base. So this becomes 2 to the 2x plus 3. Okay. Makes sense? We'll be doing a bunch of these. Okay, so the 4 we change into 2, it's 2 squared. We simplify 4 to the x to become 2 squared to the x. Power to a power, we multiply, get 2 to the 2x, and then we're multiplying powers with the same base, we add the exponents. Okay, 16 is what power of 2? Figure 2, 4, 8, 16, right? 2 to the 4th. And that's raised to the power of 3/4. Square root of 8. All right, let's kick over here for a bit. So the square root of 8. What's 8 as a power of 2? So it's going to be 2 cubed, right? So it's the square root of 2 cubed. How do we write that? Well, it's a square root and it's cubed, so it's 2 to the 3/2. So square root 8 first becomes the square root of 2 cubed. Then we change from square root from radical form to exponential form. So that this is times 2 to the 3/2. We put these two guys together, right? So power to a power. Now, if you're going to multiply, sometimes it helps to write the 4 as a 4 over 1, so you keep your numerator straight. So we get 4 times 3 is 12, divided by 4 is 3, so 2 cubed times 2 to the 3/2, which is 2 to the 3 plus 3/2. So 3 is 6 over 2. And ultimately, we get 2 to the power of 9/2. Okay. On your calculator, you want to go 3 plus 3/2. Get out the old calculator. And everything's disappearing. Let me just clear out of there. Yeah.
You can go a bit slower than you're right.
Sure. Where are we? Okay, hang on. I'll do it on here. Or not. Okay, second. Quit. Okay, so I want, what do we want? 3 plus 3/2. So just go 3 plus, and you can go bracket 3 divided by 2. Bracket, and then I just say let's go straight to a fraction, so just hit math to frac, which is enter, and then enter again, and it'll go straight to the 9/2 for you. Okay, so calculator will do fractions for you, right? So 3 plus 3/2, and then just go math, enter, enter, it'll convert it to a fraction. Make this bigger. All right. Sorry not to do that again. Somehow this computer did some special mode. So E, F, G, and H are all powers of 3. So what is 27 as a power of 3? So 3 cubed. Okay, so if we write it as a positive exponent, it's just 3 cubed. Yep. Oh, right. Did miss P. Okay, go back. It's not going to make for a good set of notes, is it? Hang on. 2 to the, cube root of 8. So what do we call that? 2 to the 3/2. 3/2, 3 plus 3/2, 6/2 plus 3/2 is 2 to the 9/2. Okay. This one is going to come up. So we want it as powers of 2. What's 1/2 as a power of 2? Well, I want to write it as 2 to the something. So how do we write 1/2 as power of 2? Well, see, it's in the bottom, so if I move it up top, I got to change it to negative. So it's 1/2 to the power of 1. If I move this 2 from the denominator to the numerator, I change the exponent from positive to negative, so I get 2 to the negative 1. That's a way that I can change a fraction into a power of 2. So instead of 1/3 or 1/27, instead of 1/3, we can write it as 3 to the negative 1. And then 64 is 2 to the 6th, x minus 3. So anytime I've got a binomial, right, two terms, make sure it's in brackets so that we remember to do distributive law here. So this will be 2 to the negative x, distributive law. This will be 2 to the 6x minus 18. And when we add negative x plus 6x, we get 5x. So 2 to the 5x minus 18. Okay. Going back down here, if I'm going to write that with, so we can think of that as 1/3 cubed. If I want to write that with a base of 3, it would be 3 to the negative 3. Okay, so the reason we want to do that is because we're going to write other things with the base of 3 and then we're going to combine them. So we wouldn't want to leave it as 1/3 cubed. So we just have to recognize 1/27 is 1/3 cubed, which becomes 3 to the negative 3 if we want a base of 3.
Was the answer to the last question 2 to the 5x minus 18?
Yep. What's 243 as a power of 3? So you might have to play with your calculator to get that one. So it's 3 to the power of 5. Yep. 5. And the x minus 2, we're going to make sure we write that in parentheses. It's a binomial, so split it out. So you can do distributive law. So we get 5x minus 10. 9 to the negative x. Well, 9 is 3 squared. Negative x, not negative 8, negative x. 3 to the x plus 1. Up top, simplify, power to a power, multiply the exponents. 3 to the negative 2x over 3 to the x plus 1. Quotient, so when you're using the quotient rule, when I divide powers with the same base, I subtract the exponents. Very important here that the x plus 1 ends up in parentheses so that you can subtract the x plus 1. Yep.
In general, that one, you have a 2 to the negative x times 2, 6, minus 18, right?
2 to the negative x times 2 to the 6x minus 18, which becomes 2 to the 5x minus 18. What?
Why is it 2?
The base is 2. The bases never change. When we use exponent laws, the bases don't change. Okay? You can change a 16 into a 2. Once you start using the law, the 2 stays. Okay, expanding this, it'll be 3 to the negative 2x minus x minus 1, right? We have to distribute this negative through the brackets. So 3 to the minus 2x minus x minus 1, which will be 3 to the negative 3x minus 1. Okay, so the final answer on that. 3 to the negative 3x minus 1. Three to the x minus 5. So I just like to put the x minus 5 in parentheses to remind me. Okay, it's a binomial. 81 is 1 over 3 to the 4th. Okay, so we're changing 81 to a base of 3. We can't work with a base of 3, and this is really a 1/3, so we're going to change that by making that 3 to the negative 4 to the 2x. Okay, so if we ever have the number in the denominator on the bottom with a positive exponent, just promote it up top, move it from the denominator to the numerator, change the exponent positive to negative. Okay, so now 3 to the x minus 5. 3 negative 4 times 2x is negative 8x. 3 to the negative 8x. So we get x minus 5 minus 8x. So x minus 8x is negative 7x minus 5. Okay. Simplify the following, write as a single power if necessary. So what we're going to do with this is we're going to work inside the brackets first. Okay? So we'll do inside the brackets. We got 3 to the 20. I've got a 9. We're going to turn that into 3 squared. That's to the power of negative 8. Over 3 to the 5th. That whole thing is squared. So the first step is change the 9 into a 3, right? Let's get everything with the same base. So 3 to the 20 times 3, power to a power multiply. We've got negative 16 over 3 to the 5th. That's all squared. So we've got 20 plus negative 16. So just write that as 20 minus 16 minus 5 because that's in the denominator. So here we're adding. Okay, but instead of writing 20 plus negative 16, we just write 20 minus 16 minus 5 because that's in the denominator. So we subtract. So we got 20 minus 21 is 3 to the negative 1 squared, which is 3 to the negative 2. Write as a single power. So probably write that as 1 over 3 squared. Or even 1 over 9, because we can actually evaluate it. And they'll tell you if they want positive exponents or negative exponents are okay. It'll say if it's multiple choice and you look, you might see that they're all positive exponents. So just whatever you get, you change so that it has a positive exponent. So sometimes you'll look at the answer and the answer will be, you'll have the right answer, you just won't see it in a multiple choice question. Then what you want to look at is say, okay, is the answer that I have, is that written there, it's just in a different form. So for example, I have 3 to the negative 2, but they have 1/9, right? Those are the same. So you just have to recognize, oh, I got to keep going with the 3 to the negative 2, make it 1 over 3 squared, make it 1 over 9. This guy, so everything's got to be changed. So this is 5 to the 3 halves. This is 5 to the 1 half. This is 5 to the 4/3. So 5 to the 3 halves times 5 to the 1 half over 5 to the 4/3. We can add these two guys. 3 halves plus 1 half is 4 halves, or 2, over 5 to the 4/3. So we've just added these exponents, multiplied powers with the same base. You add 3 halves plus 1 half, 4 halves, which is 2. Becomes 5 to the 2 minus 4/3. 2 is 6/3. Okay, so in order to add or subtract fractions, we need a common denominator. And we'll end up with 5 to the 2/3. Okay, so that's as a single power. And if we needed to, we could change it to the cube root of 5 squared. Okay, so all of that will be equal to the cube root of 5 squared. So that would simplify down to. If we went back into a radical form. Okay, so that's exponents. And now we're going to solve some equations involving exponents. State the values of x. We don't have to show any work. Just state the values of x to satisfy the equation. So when we say x squared is equal to 9, we have to remember that you can square positive 3 and get 9, but you can also square negative 3. So when you're solving for a squared, the other side becomes plus or minus. Okay, when you have an expression x squared equals 9, recognize 3 works and negative 3 works, right? Plus or minus. For a cube, it's only positive. Right? So if it's the cube root of positive 8, that's 2 times 2 times 2, because negative 2 times negative 2 times negative 2 will give you negative 8. So for an odd root, it's positive, the answer is positive, the root is positive, and if it's the odd root of a negative, then the answer would be negative. For an even root, squared, fourth, whatever, you'll have a plus or a minus. Solve each of the equations algebraically. So what we want to get is x. So here's how we do it. We take x to the 3 halves, and we take that to the reciprocal power. So we flip the power over and say, we're going to take that x to the 3 halves, but we're going to raise it to the exponent of 2/3. Now, to keep things equal, if I raise the left side to the power of 2/3, I have to do the same thing to the right side. So it becomes 27 to the 2/3. X to the 3 halves to the 2/3. When you multiply these, you get 6 over 6. Basically, we're multiplying reciprocals, which is always going to give you 1. So that's just x. This is the cube root of 27, then squared. Right? So we're now changing from exponential form, right? 2/3 means nothing. How do you even multiply a number by itself 2/3 of the time, right? That doesn't make any sense. So changing it to the cube root squared, the cube root of 27 is 3. So this is x is equal to 3 squared, or x is equal to 9. This is to the power of 2/3, so we're going to raise it to the power of 3 halves, and we're going to do the same thing to the right side. So we raise it to the power of the reciprocal exponent, right? We just flip the exponent. And the reason is, when these two multiply together, you get 1. So this is x to the 1, and we never write the 1, is the square root of 16 cubed, which is 4 cubed, which is 64. Okay, so we raise both sides to the reciprocal exponent, which in this case is 3 over 2. The left side just becomes x, because 2/3 times 3 halves is 6 over 6, which is 1. The right side becomes the square root of 16, which is 4 cubed, which is 64. This guy's x to the 2/5. We raise that to the power of 5 halves. We do that to the same thing, raise 4 to the power of 5 halves. Left side just becomes x. This becomes the square root of 4 to the power of 5, which is 2 to the power of 5, which is 32. So we work our way through, and we end up with 32. Solve algebraically. X to the negative 2/5. The reciprocal exponent is negative 5/2. So if the exponent is negative, its reciprocal is also negative. That's 4 to the negative 5/2. Negative 2/5 times negative 5/2 is positive 10 over 10, or 1. So this side's always going to work out to x to the 1. This is 4 to the negative 5/2, which is 1 over 4 to the positive 5/2. So first make the exponent positive, then change it to radical form, so it's the square root of 4, which is 2 to the power of 5, which is 1 over 32. Very important in the next one. We don't want to raise it to the power. We don't want to do that with the 2 on the left-hand side. We want to get rid of this 2. So we're going to divide both sides by 2. So basically, we need to isolate the power. We need to isolate the x to the 3/2. Then we raise to the power of 2/3. 64 to the 2/3. This is just x. This is the cube root of 64, all squared. Which gives us 16. Last one, same deal. You cannot work with the x to the negative 2/3 when there's a number there. So we have to divide both sides by 125. You have to isolate the power, the x to the negative 2/3. Then you say, all right, well, we know how this works. So I'm going to raise it to the power of the reciprocal, which is negative 3/2. I'm going to rewrite, instead of 5 over 125, that's the same as 1 over 25. That also has to be raised to the negative 3/2. This is just x. Flip the 1 over 25, so it just becomes 25. And the exponent becomes positive 3/2, right? But we have a fraction, 1 over 25. And a negative exponent, we flip the fraction, 25 over 1. The square root of 25, all cubed, which is 5 cubed, which is 125.
That's it.
That's it. Wait, one more we should be looking at. So what I'm going to do, I'm going to save this. So review exponent laws. Well, you know what? We're almost at the end. So